Question 6b, part 2, it says hence or otherwise solve for x if f of x multiplied by g of x is less than or equal to 0. So this could be done on the table. So we make a table with the product of f of x and g of x, and we want the resultant to be less than or equal to 0, which basically means that f and g have to have opposite signs. So when I multiply them, I get a negative answer, including 0. So this is possible if f is positive, and for the same set of x values, g is negative. So I'm going to call this solution number 1. And alternatively, this could also hold true if f of x is negative and g of x is positive at the same set of x values. If I explore option number 1, f is positive and g is negative will occur on the left of the x-intercept of g of x, which we calculated previously in question B1, which was minus 5 over 2, and that's going to continue all the way up to negative infinity. So for option 1, the solution is going to be x is an element from minus infinity to minus 5 over 2, and this can be included since we're including 0 as part of the product. And then similarly, for solution number 2, we're now looking for where f is negative and g of x is positive at the same set of x values. That's going to be true between the x-intercept of f of x and its vertical asymptote. So that's going to be between x is an element, and if you recall, we calculated the x-intercept of f of x to be negative 5 over 3. So that's going to be from negative 5 over 3 all the way to negative 1. Negative 1 we cannot include since it's an asymptote. So the answer will be between negative 5 over 3 inclusive and negative 1 not inclusive.